Hello students, I am Professor Deepak Bora and I welcome you to the last type of indefinite integration, which is integration by partial fraction. One of the very important types from the exam point of view, and obviously you will require this in your further studies, that is in your engineering as well. So let's see what is there in store for us in this particular module. First, let us understand the fractions. Proper fractions and improper fractions. So let us see what they mean. Now my dear students, if you have two functions f of x and g of x which are polynomials of x, then the ratio f of x upon g of x, if g of x is not equal to 0, is called as a rational function of x. This you have very well understood in the chapter continuity as well. Now my dear students, if I have to go further to explain it, if degree of f of x is less than degree of g of x, that is degree of numerator is less than degree of denominator, we call it as a proper rational fraction, correct? If it is not, then we call it as an improper rational function. Now my dear students, our problem begins if it is an improper rational function. Let's see what is supposed to be done then. In case of an improper rational function, that is, if degree of f of x is greater than or equal to degree of g of x, then divide f of x by g of x and express the function using something like this. F of x upon g of x is equal to quotient plus remainder upon g of x. Now my dear students, remainder will always have degree less than the divisor. So can I say, in this case, remainder upon g of x will be nothing but a proper rational function. These are some basics regarding proper and improper rational function. Now let's understand what are the steps or the rules for partial fraction. For us to apply partial fraction, the very first rule is degree of numerator should be less than the degree of denominator. My dear students, a very big less than, because it's a very crucial condition for you. So that is the first condition. The second condition is the denominator has to be expressed as product of distinct linear terms. Now this is not a very compulsory condition because there are two exceptions which can be still managed. Now if these two conditions are satisfied, we can apply partial fraction. Now let us understand the rational form and the corresponding partial form. If I have something of the form px plus q upon x minus a into x minus b, then its partial form will be a upon x minus a plus b upon x minus b. Likewise, I may have some quadratic in the numerator and I may have three terms in the denominator such as x minus a, x minus b, x minus c. In such a case, the partial form will have a upon x minus a plus b upon x minus b plus c upon x minus c. So product is getting converted into addition, and that's why integration becomes easy. Let's see an example and understand what is supposed to be done. The question says integral of 2x upon 4 minus 3x minus x square dx is equal to what? Let's see the solution, my dear students. So let's first copy the question. Now very first thing is I have a quadratic where coefficient of x square is negative and I don't like that. So let's make the coefficient of x square positive. So can I write in the next step 2x upon minus of x square plus 3x minus 4. I am taking a minus common just for my understanding. Okay, my dear students. Now if I compare the degree of numerator, can I say degree of numerator is 1 and that of the denominator is 2. So can I say first condition, degree of numerator and degree of denominator, they are satisfied, correct? Second condition, let us understand before what is to be done. We have 2x in the numerator, or to be precise minus 2x, and denominator is a quadratic which I can easily factorize. The factors, or on factorization, what do I get? X square plus 3x minus 4 will give me x plus 4 into x minus 1. Can I say I have two terms in the denominator, both are linear, so can I say distinct linear terms? So condition of partial fraction is satisfied. So let's apply partial fraction. So let's write in the next step, this LHS is equal to a upon some x plus 4 plus b upon x minus 1, where a and b are constants which we need to find. Now my dear students, to find that, let's take LCM. So the left hand side will be only minus 2x and on the right hand side I'll get a into x minus 1 plus b into x plus 4. Our job, students, is to find the value of a and b. Let's see how to find the value of a and b. The simplest way of finding the value of a and b is make the value of the other term 0. So if I have to find a, I will make the coefficient of b equal to 0. A coefficient of b is x plus 4. That means x plus 4 should become 0. And if x plus 4 is 0 means x is minus 4. So to find a, we will put x is equal to minus 4. So on the left hand side, I'll get a minus 2 into minus 4. And on the right hand side, I'll get a into minus 4 minus 1. That is, 8 is equal to minus of 5a, or a is equal to minus of 8 by 5. Likewise, if I have to find b, I'll make coefficient of a equal to 0. That is, x minus 1 should be 0. And x minus 1, 0 means x is equal to 1. So let us put x is equal to 1. We get minus 2 is equal to b into 5, or b is minus of 2 by 5. Now my dear students, once a and b is done, can I say minus 2x upon x plus 4 into x minus 1 is equal to, now it was a upon, so minus 8 by 5 upon x plus 4 plus b upon, so minus 2 by 5 upon x minus 1. So the product converted into addition. So the integral will look like minus of 8 by 5 integral of 1 upon x plus 4 dx minus of 2 by 5 integral of 1 upon x minus 1 dx. Both are linear in the denominator, so directly we can write the integral as nothing but log. So can I say minus 8 by 5 log of x plus 4 minus 2 by 5 log mod of x minus 1 plus c, and that's our final answer. That's how we are supposed to solve sums based on partial fraction. That's all I have in this module, my dear students. Thank you very much.